Okay, guys, so here starts our videos for chapter 19. Testing hypotheses about proportions. We'll be referring to this as our significance test. So just a quick intro here. A significance test is a formal procedure for comparing observed data with a claim, also called a hypothesis, whose truth we want to assess. The claim is a statement about a parameter like the population proportion P or the population mean mu. We'll be focusing first on the proportion as we've been doing so far. We'll talk about the mean in our next unit. We express the results of a significance test in terms of a probability that measures how well the data and the claim agree. So let's kind of put it into terms a little bit better for us to understand. So let's say that there's a product out there that they say there's 100% customer satisfaction. So we might be a little hesitant on 100% customer satisfaction. We might think that they are exaggerating a bit, right? So how could the actual proportion for the population be true? How can that 100% true be the true proportion there? So we can test this claim by using evidence from a sample in order to see if our evidence is strong enough to show that it would actually be less than 100%, that it wouldn't be 100. So let's talk a little bit more about these claims that we're starting to see that we're making. So with this idea of the 100% satisfaction with the company, so the product, or I should say, I guess the company is claiming that there's 100% satisfaction. That's the one part of it. That's your one hypothesis. Your other hypothesis is what we're saying, which is that we think it's going to be less than 100%. So those are the two claims. Those are our hypotheses. So a significance test starts with a careful statement of the claims we want to compare. The claim tested by a statistical test is called the null hypothesis. So the null hypothesis is a statement of no difference. So the null hypothesis says it's no different. It's the claim that is originally being made. So our null hypothesis for our company would be the 100%, that the proportion is equal to 100%. So this is how we denote our null hypothesis. So for our company, it would be that our null hypothesis for our proportion would be equal to the 100%. Okay. The test is designed to assess the strength of the evidence against the null hypothesis. So you're trying to build a case against the null hypothesis. So the claim about the population that we are trying to find evidence for is the alternative hypothesis. This is the claim that we hope or suspect to be true instead of the actual null hypothesis. So you're looking for evidence that would support the alternative hypothesis that would go against your null hypothesis. So just as far as how you can write that for our company. Oops, ran out of space there. Your alternative hypothesis is that your proportion is actually less than 100%. I'll write it over here. Okay, so let's just take a look at what our hypotheses may be here. So the example here is that at the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wonder how this change will affect the mean weight for the pineapples grown in the field this year. State the appropriate hypothesis for performing a significance test. Okay, so we just want to write down what we think our hypotheses are. So our null hypothesis, that's going to be our no change. We're talking about the mean weight here. So our mean weight would be the 31 ounces. Okay, so our null hypothesis is assuming that nothing's changed. Sorry, not 30, 31. Is assuming that nothing's changed, so it would still be the 31. Our alternative hypothesis is checking to see if there is a change, okay? Now, it doesn't say what, it just says that there's a different irrigation system that was installed, and we're wondering how it would change. We don't know if it will harvest more than 31 ounces or less than 31 ounces. We just are claiming that, is it going to be different than 31 ounces? So we're saying, is the mean going to not be equal to 31? So we can have a less than, we can have a greater than, or we might not want to specify which way we think it's going to be, but just say that it's not the null. Okay. So for in any significance test, the null hypothesis has the form as follows. The alternative hypothesis has one of the forms that I wrote on the bottom of the last slide, okay? That it's either going to be less than, greater than, or it's not going to equal what it did in your null hypothesis. So to determine the correct form of H of A, read the problem correctly. Okay. So the alternative hypothesis is one-sided if it states that a parameter is larger than the null hypothesis value, or if it states that the parameter is smaller than the null hypothesis. So, so we're looking at one-sided being you're less than or you're greater than. So if you have this or your alternative hypothesis greater than. So it's going to be two-sided if it states that the parameter is different from the null hypothesis. It could either be larger or it could be smaller. So this would kind of be a two-sided test, would be if you're just saying it's not equal to the value. Okay, so a few more things about a hypothesis. So hypotheses always refer to a population, not a sample. Be sure to state your null hypothesis and alternative hypothesis in terms of the population parameters. It is never correct to write a hypothesis about a sample statistic such as p hat or x bar. So it would just be for the population p or the mean mu. So let's just write some hypotheses for these. So for each of the following settings, we're going to state the appropriate hypotheses for a significance test. So according to the website sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks an SRS of 100 students at the school how much sleep they get on a typical night. In all, 75 of the responders said less than 8 hours. So if she had 75 respond, 75 out of the 100 respond, it would appear that she's claiming that this 85% might be a little too high, that she might think it's lower than that. So our null hypothesis is going to assume that there is no change, that what sleepdeprivation.com is saying is true. that the actual proportion here would be 0.85. The alternative hypothesis here would be that the actual proportion is less than the 0.85. Okay, so another problem. So as a part of its 2010 census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes, that's all it takes. On the census for itself, for the average household, this form will take about 10 minutes to complete. Sorry, the volume cut out there for a second. Where was I? The U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers. We suspect that the actual time to complete the form may be longer than advertised. Okay, so we're talking about a null hypothesis. This time we're talking about mean would be 10, the 10 minutes. And our alternative hypothesis is saying that we think it may be longer. So those would be our two hypotheses for our significance test. So one more quick example, studying job satisfaction. So does the job satisfaction of assembly line workers differ when their work is machine-paced rather than self-paced? One study chose 18 subjects at random from a company with over 200 workers who assembled electronic devices. Half of the workers were assigned at random to each of two groups. Both groups did similar assembly work, but one group was allowed to pace themselves, while the other group used an assembly line that moved at a fixed pace. After 2 weeks, all the workers took a test of job satisfaction. Then they switched work setups and took the test again after 2 more weeks. The response variable is the difference in satisfaction scores, self-paced minus machine-paced. State an appropriate hypotheses for performing a significance test. So because the initial question asked whether job satisfaction differs, the alternative hypothesis would be two-sided here. So we're saying it's either one way or the other. It's either smaller or bigger. So we're not specifying just one side of it. So our null hypothesis here would be that it is equal to 0 or not equal to 0. And that's it for our first video.